Here we are, you guys, for temperature and volume. So what is that relationship between temperature and volume? So basically, we know that temperature is going to go up and down, and we know that volume will get bigger or it will get smaller. And so we would say that those two are directly related. And when we say something is directly related, we basically are saying that when one goes up, the other one goes up. When one goes down, the other one goes down. So we've already learned about pressure, but now if we're learning about temperature and volume, we would say that pressure is held constant, which means pressure doesn't have really anything to do with the relationship between these two. So the trend between temperature and volume is that if the temperature is going to increase, the volume will increase. Just like I said, direct relationship. So if they both increased together, what's going to happen if the temperature increases? You got it. The volume will decrease as well. If we were in a general chemistry course, this is what it would look like if we used an equation to go with it. But in this course, we are not going to be using an equation, but you can see that they do have a direct relationship with one another. We call this temperature and volume relationship Charles' Law. And so Charles' Law, with this nice little picture here, shows you that if we have 300 degrees or 23 degrees Celsius, you can see that the temperature is lower, so the volume is lower. Those gases are kind of stuck together moving around. As we increase the temperature exponentially here, the volume gets bigger. And why? What are those little molecules doing? Well, we've learned in the past that when the temperature increases, those little particles are going to move a little bit faster. You guys did that in your particle mini model demonstration. So as those particles start moving faster and faster, they're colliding with each other, and they're also colliding with the walls of the container. So they're going to press more on the sides, making that volume bigger. Absolute zero. So what is absolute zero? Well, absolute zero happens at 0 degrees Kelvin. And what this means is that this is the temperature where the volume of the gas becomes zero. Pretty crazy concept to think about. And so that volume becomes absolutely zero. Things aren't moving anymore. We're at absolute zero. Those molecules completely stop moving, which is hard to fathom because we've already been taught that a solid still vibrates in place. So there's a formula that we use if we're using Kelvin, and that formula is Kelvin equals the degrees Celsius plus 273. Whenever we are doing any calculations involving these, we're always going to be using Kelvin as a temperature. So there might be times where we're giving you Celsius, and you have to be able to convert it to Kelvin. So just remember, anytime you're given Celsius, you add 273 degrees. If you're given Kelvin, you will subtract 273 from it. Okay, so we're going to spend a second here going through a few questions on the bottom of your note sheet. So my first question, if we're talking about temperature and we're talking about volume, what would happen to a balloon on a cold day? Go back to that relationship, that direct relationship of what you wrote down at the beginning to answer that question. Next question. What would happen then to a balloon on a hot day? Be sure to explain both of those and say why in terms of particles and their movements. I've got a video on Charles' Law that will show you guys how that representation works.
The second gas law we're going to look at is Charles' Law. And Charles' Law is what happens when about the volume and the temperature. And in this case, we're got to keep the pressure the same. Okay? Got to keep the pressure the same. Now, what we're going to do is, as you can see, there's some flames under this box. Ooh! Which means the temperature's going to rise. But if we've got to keep the pressure the same, what's got to happen to the volume? Well, let's see what happens when we keep the volume the same and the temperature goes up. Ooh, ee, ah, ee, ooh, ee, stop. Wow, what was, when the temperature went up and the volume stayed the same, we bounced off the walls and we bounced off each other, which means the pressure went up, and that's no good. So what have we got to do to keep the pressure the same when this funny little flames tickle us from below? Have a guess. Well, the challenge was to try and keep the pressure the same while these flames tickle us from below. Now, if you've guessed that we need to increase the volume of this container, you were right. Look, let's start off in this normal sized container. Watch it as bouncing off the walls. Ooh, ee, ooh, ee, ooh, ee, ooh. Now, the bouncing comes on underneath, but let's double the size of the container. Ooh, ee, ooh, ee, ooh. Ah, that did it. We kept the pressure the same. That was a demonstration of Charles' law, that volume being directly proportional to the temperature when we keep the pressure the same. See if you can remember that one.
How'd you like that funny little guy? One last video for you, eggs in a bottle. This one's pretty cool. Will sure to entertain you.